Good morning, good afternoon, or good evening from wherever you are. I'm Ed Kohler with Avaya, and I'm here to talk with you about network security again to kick off 2017. This time I want to talk about the notions of a network perimeter and what it's all about, and how it's changing drastically, whether we like it or not. This is a big problem. It's actually growing day by day. We've seen a 38% increase in security incidents, a lot of those revolving around IoT devices. Now, when we think IoT, there's two directions you can think. You can think the one end where we start thinking about automated production. We start to think about, smart grids, smart buildings, smart city infrastructures. All of those are usually set within a well-maintained and documented IT environment. There is another set of IoT that is much less so, and this is the consumer side of the IoT market. Many of these devices are used many times in tandem in corporate environments as well, such as employees, things of that nature, bringing their own IoT devices into work. But the point of the matter is that these boundaries are becoming very soft. The notions of a perimeter are starting to change. As a great example of that is the recent denial of service attack that occurred against Dynamic DNS on the Eastern Seaboard. While there was no direct compromise of any of the enterprises that were impacted, they were all severely impacted, many of them taken offline. So we have to realize that our notions of a perimeter are starting to change as our dependencies on services. And as we start looking more and more into cloud dependencies, this is something we're going to have to take into consideration. Now, the notions of a network perimeter in the past were pretty easy to understand. You had your internal network, and then you had your hard security boundary with your firewalls, and then outside you had everyone else. And maybe you had extranet VPN technologies in order to allow remote access, and that was about it. But the IoT, as I said earlier, is starting to change, and really the perimeter is starting to basically be everywhere. One of the big drivers for this is IoT, but also cloud, and I mentioned that earlier as well, is that when we start to merge IoT and cloud together, we start to see the notion that you really can't draw a hard perimeter anymore. And then we have the growing aspect of BYOD. People are still buying more devices, bringing them to work, expecting them to use them, and we need to handle that security avenue as well, and realize that really BYOD is really just another morphing of the IoT experience. And eventually people will be wearing these devices or even having them embedded in clothing or within their vehicles. So we have to realize that that's starting to change as well as far as what a normal user interface is. As a matter of fact, there's a lot of work going on for voice technology so that I don't need a keyboard or a monitor anymore. I can interact with a computer on a verbal basis, which makes something in an automotive environment a realistic type of proposition. And then our contracting and outsourcing, that continues to expand. We are still doing that on a regular basis, and there is some question as far as how we handle the security approach for these types of individuals within our environment. So we have to start asking how do we go about safeguarding our critical applications and data, and then more importantly, containing hackers. Because the fact of the matter is that if you are targeted, particularly by an advanced persistent threat, you probably will get compromised. The question is how far they get and how much data they get. And this gets down to the tandem lower bullets where we start talking about protecting the people, the places, and the assets as they move about, given the fact that they're usually the targets for that type of breach. And then finally, how do I onboard, manage, and secure IoT? That becomes a big thing because you're going to be dealing with a lot of devices of different nature, and you have to make sure that you have some consistent process in order to onboard them and manage them. And that tandems to the compliance and regulatory obligations. And we have to realize that while they themselves are not a security practice and they don't do anything to help you, if you do comply to them, then you know you've met the minimal bar. And that's a key point, is that compliance and regulatory obligations are the minimal bar. They should be understood as such. You shouldn't meet those compliance and regulatory obligations and then say, okay, my job is done. You really should be constantly looking to improve your security practice. And this gets to the notion of securing the everywhere perimeter. And there are three main principles that SDN Fx is based upon to allow for that notion. The first is the aspect of hypersegmentation. The second is the aspect of the native stealth nature of the SDN Fx fabric. And then finally, the ability for automatic elastic extensions of the hypersegmentation environment. These are three key principles that we'll talk about through this session. Now, the power of segmentation is rather obvious. From NSA's recommendation, we see that's one of the four top bullet statements that they make is segment networks and data. And that's important if you're going to limit access to important systems and provide the right kind of protection through, for instance, application whitelisting and security demarcation points leading to them. And then the last bullet stands for itself, remove hard-coded passwords, but I do want to note that it was the hard-coded passwords in those IoT devices that caused the denial of service attack that occurred just a month ago. Now, we did some work with VeriQuest and went out and talked to a number of customers and a number of end users in the environment. And while 100% agree that segmentation is somewhat essential to a security practice, over 77% do not deploy end-to-end segmentation. An interesting point is that there is a dichotomy on the rationale of why. 67% of those who didn't deploy kind of thought, okay, it's too complex, I can't manage it, it's too costly, and there's a lot of risk associated with the practice. And then there was another 22% that didn't even realize that it was possible to do as such. So this needs to change. Given the NSA's recommendation, we all have to start to get used to the concept of segmenting out our environment. The question is matching the right kind of technology to accomplish that end goal. So hypersegmentation is one of the key pieces that allow SDN Fx to be a very effective microsegmentation technology. Hypersegmentation is based on the concept of a holistic knowledge fabric. In a traditional network architecture, when you want to do a microsegment, you need to deal with various technologies, various protocols, and all of those sit at various levels, and you, the human being, you, the administrator, need to orchestrate the policies and the rules to basically constrain that domain of interest. With hypersegmentation, that becomes automatic. The zones are seamless across the network. It really becomes a question of end provisioning or SDN Fx edge automation for provisioning, and the fabric will basically extend the hypersegments based on the required provision paths. Now, that's an important aspect because what this does is it brings a vast degree of scale to the IoT deployment and to your ability to provide the appropriate microsegmentation environment underneath. And hypersegmentation is very key to making that a reality. The stealth advantage kind of goes along hand in hand. Without stealth, the network is more or less open, and many networks are surprisingly open in the way they're designed once you get past the security demarcation. Here we see perhaps a security guard that decides that he needs to make some more money some other way, so he starts to use the system in order to discover other aspects into the network. So this is a great case of example of an insider threat. With stealth technology, he would be limited to that microsegment and only the resources that he's required to do his job. He would have no ability to do any discovery outside of that zone. Everything else is dark. So even if he decides to be malicious in the zone that he was hired for as a contractor, a security contractor, for instance, he really can't gain anything outside of the systems that he's normally allowed access to. And we, of course, would pick up that anomaly very quickly and be able to nab the culprit fairly easily due to the fact of his isolated abnormal behavior. Now, the elastic advantage is the third and final piece, and this is the ability for the automatic attachment to the fabric edge through the use of the auto-attach protocol and fabric attach. Now, the concept here is that we have a video surveillance environment and an IoT camera is moved, or think of a sensor moving or something of that nature, and plugged into a different location. Notice how the hypersegment itself is retracted upon disconnection of the camera, and as the cameras move to the new location, the hypersegment is automatically and dynamically extended back out based on secure authentication. So this is what we mean by the elastic advantage for IoT provisioning. So let's kind of take a look at an overall architecture view. We have Obviously, the Fabric Connect feature within SDN Fx, and that is shortest path bridging as the protocol. We see that we also have the Fabric Attach feature, which allows us to have the elastic advantage. Now, the elastic advantage is directly tied to hypersegmentation, and hypersegmentation is provided by Fabric Connect. Based on the fact that everything is an Ethernet switched fabric, there is no use of IP as a protocol from a utility standpoint. It's not used in the end-to-end data forwarding, so the whole environment becomes very dark and stealth. Down below, we see that we have identity engines, which provides the ability for authenticating users and the ability for the elasticity to be extended based on authentication. And then we also see the SDN controller, and that provides master control of the environment and also reaching out to the open network adapter at the top of the slide. This is an edge compute component which allows us to extend the intelligence of the fabric directly to an attached networking edge. The Surge Healthcare solution is a great example of that, and the first that we've delivered, but look for many more. This allows dynamic extension of the hypersegmentation environment. And then finally, let's talk about Fabric Extend, which is the ability actually to move fabric information across an IP transport, usually for migration purposes, but many times you need to have intermediate transport against traditional RANs, third-party cores, or provider networks, and the Fabric Extend feature allows for that to occur. Now, what I'd like to do at this point is just talk about some use case examples. I mentioned Surge and the healthcare use case. This is actually what we've done. Really talks about device tracking, the ability to prohibit, software additions to devices and things of that nature, and protecting them from additional utility code, which may be malicious. Securing the medical devices themselves is a key piece of that. So the ONA provides a very intelligent device proxy at the edge, and this also is a key piece that allows us to deliver the tracking and flow control of the environment. In the education use case, we deal more with pervasive smart devices. So we really need to think about student network security, not only protecting students from the internet, but also protecting them from themselves. And then also pervasive recreational wireless applications, the ability to support them, but support them on a limited basis. And this is some of the key things that we need to see because, interestingly, students need to have rather ubiquitous access to the internet, and yet on the same side, you have student records, perhaps PCI for financial transactions, things of that nature, which definitely need to be segmented away from that type of activity zone. Government use case kind of extends the same thing, except here we're looking at using hypersegmentation to deliver departmental traffic segmentation. It's very key because in most government use case examples, there really is minimal IT resources. And then secondarily to that, the multicast performance is often well cited within several of the state and local government use cases that we have for not only video surveillance, but also internal video use, internal broadcast. There is often the need for traffic zone monitoring and also SCADA traffic, the ability for us to transport SCADA over considerable distances using transparent L2 services. Manufacturing use case really focuses around securing the supply chains, creating good, firm, secure business-to-business environments, device tracking and flows, and obviously a very large granular set of IoT sensors, controllers, so forth, so on within the automated environment. Note how there's the need and ability for live line manufacturing zones and then also R&D zones, which can basically mimic flows, things of that nature in a very granular basis if required. Note also that these can be temporary, so you may have R&D zones being created and then deleted over time as they get morphed and obviously evolved into the real-time manufacturing line zone. And then finally, we have oil and gas, which is critical for digital monitoring, geologic information, things of that nature, physical protection of the infrastructure, realizing that much of this is out in the middle of nowhere, and then finally, cyber protection for the overall environment. We see a lot of parallels to the government use case in the fact that we have physical security zones, we have video surveillance cameras, we have production zones, which kind of are represented in an IoT fashion. i.e. Oil and gas production, IoT type components, and then the SCADA traffic as well for pipeline zones, things of that nature. And keep in mind that SCADA traffic and production zones may often work in tandem, if not blended together. And then on the other side, we see that we have the normal employee service zones, things of that nature, billing for customer relations, things of that nature. So that really talks about the three main principles, kind of went over them, went over the advantages and definitions of what they mean, and then we provided some brief overview on use cases as far as how they can be used. So I hope you found that informative. And again, I'm Ed Kohler with Avaya. If you have any other questions on SDN Fx for security, please reach out to your local Avaya representative. Thank you, and have a great day.